Hello, I'd like to share with you my methods of constructing O-gauge rolling stock from scratch. The material I use is from steel cans, steel drums, two types, 25 litres, which are used by garages, particularly involved with coach building, body repairs and resprays, in this case standard thinners. It's a fairly thick material, can be used for virtually anything. This is 25 litre. I also use stock 20 litre drums, which can be obtained from people who use cooking oil, in this case from a local Chinese restaurant. This material can be used for just about everything, and I will demonstrate in the course of this video how I use it for everything, all the components involved in producing these kind of wagons, HEA type coal wagons. All the components on here, apart from the wheels and the bearings, were constructed from the material that I've just shown you. I'm building currently a fleet of 10 of these vehicles, and they will be built for virtually nothing more than the cost of the wheels and the bearings. And it also provides the opportunity for anyone who wants to build a train that's otherwise unobtainable. They can build anything, however obscure, and the other advantage of course is that it's all your own work. The design and everything can be carried out by yourself, providing you with that satisfaction. The first step, of course, is to prepare your drawings. Most drawings will be available in 4mm scale, as in this case. You simply do your own drawings and scale them up, in this case to 7mm scale, and at the same time planning exactly how the components are going to come together and be folded. This is then simply scribed onto the sheet metal, and once this is done, the shapes are simply cut out using a pair of ordinary tin snips. Nothing particularly special about these, they're just ordinary tin snips, must be kept sharp of course, and the shapes are cut out according to how they've been scribed out. Accuracy is important of course, because if these things don't come together right then you'll be out of true at the end, but alterations can be made. It's easy to make adjustments when mistakes occur. When beginning to fold these up, the most important thing is to do the edges of the metal first to provide safety and to provide extra strength. So a first fold is always the first thing that's done along all the edges before the main folding up process takes place. Okay, we've reached the stage now where the entire shape has been cut out. Before I finally fold this up, as you'll see all the edges have been folded over, I scrape the paint off the joints here where we soldered together once it's been folded up. So the next phase is to fold this together. Having folded the body of this hopper in its correct way, we now get to the point where we carry out the soldering. As you see, the tabs have all been prepared, checking of course that everything comes together nicely, as it does here. It seems to be okay. Using plenty of solder and plenty of flux, so let the solder to run in the joint. Plenty of solder, ordinary soldering iron, nothing special about this at all. Powerful soldering iron. Use as much heat as you like. No danger here of damaging any delicate castings or anything of that sort. So just keep the soldering iron on and allow the solder to run into the joints. And once it's together, finish up by soldering on the outside, and that can then be rubbed down to provide nice joints. The manufacturing of the underframe follows the same process as the main body, cut out from the sheet metal and then folded up. As you see there, one fold to start with, again for safety reasons and to provide extra strength. Second fold there to produce the shape of the underframe, where the buffers will go on the end of there eventually. Now all of these other parts are manufactured from the offcuts that are left over, and I manufacture just about everything else from offcuts, including one of the most important components, which is the axle box assembly. And here you see the bearings have been put in there. It doesn't look very strong at this stage, but it is reinforced later by the addition of various brackets and struts which are added onto the assembly. The leaf spring assembly is also added from offcuts. This is looking a bit rough at the moment because it hasn't been prepared, but eventually it will be mounted on the underframe in that manner with two bolts. Obviously two underframes produced, two axle boxes. Other offcuts are then used to produce things such as the ladders, brake handles and brake operating levers and things of this sort, and various other brackets and struts which go together on the final assembly of the train. You can see it best from this example here, where this is a finished model, and you see the axle boxes here. You see the strength in this assembly, a nice free running bogie wheel sets, and everything there very robust. All the struts added, just waiting for final preparation before painting at this stage. Now once painted, my final livery, my intention is to produce them in this livery. This is the British Rail 1970s rail freight distribution livery that was used for the coal traffic, and you can see here also I own springs that I produce for the couplings. They're very, very strong. They need to be robust because these trains are intended to be run out in the garden, which is obviously quite a harsh environment, and they need to be robust for that reason. Well, I hope that I've inspired you to take up the challenge of building these vehicles from scratch using this material. Virtually anything can be done with this material. I have, as it happens, an example here of a pantograph built from this material as well.